All right. Hello.
Hello.
All right. Good morning, class. We are doing math. Yeah.
Oh my god, I love
Get some.
mitochondria. Can I see it?
All right. So we're finishing up these notes. So if you paid attention yesterday, what did I do with this thing?
You made it look different.
Made it look different. Okay. By making it look different, what do I need to use L'Hopital?
We need a denominator.
I need a denominator. Can we put a denominator in there?
Yes.
Okay, yeah, let's do that. So how would I do that?
The X.
Move the x
Under.
under to the bottom, right?
Yes.
Okay. So let's do that. So let's move the x to the bottom. So I'm going to have sine of 1 over x over x to the negative 1, right? Say yes.
Yes.
X to the negative 1. So now I actually have okay, so now what do I gotta do?
Take the version.
Nope.
Plug in 0.
Plug in
Oh.
infinity, right? Alright, so plug in infinity. So now there's a couple things you have to remember. Sine. Sine is a wave, right? So it is a wave. So that's a normal sign. But 1 divided by infinity. Infinitely smaller. So 1 divided by infinity goes to what?
0.
0. Thank you. 1 divided by infinity goes to 0. So what is the sign at 0? 0. Okay. Over. Now, I'm gonna rewrite that x to the negative 1. 1 over x. So 1 over x, right? Again, 1 divided by infinity. 0. So using this, I now showed that I have 0 over 0, which is the, what's the word? Indeterminate. So I have the indeterminate now. So now that I have the indeterminate, now I can actually do L'Hopital's rule. So the derivative of sine, okay, so this is going to be a chain rule here though. Chain rule, okay? So the derivative of 1 over x is,
1 over x squared.
so yes, it's negative 1 over x squared, right? Negative 1 over x squared, right? Times the derivative of sine is cosine of 1 over x. Very good. Divided by, so there it is again. There is my x to the negative 1, right? So the derivative of this, the derivative of the bottom right here, is going to give me what? Negative 1 over
X squared.
very good. So negative 1 over x squared. Ooh. Ah. Happy day. Why is this happy day? Yeah, get rid of that. Right there. Wow, that was ugly. Let's see, can I undo that? Nope. Can I undo that? Nope. Can I undo that one? Nope. Either way, it doesn't like me. Yes, I do. No, look at my whiteboard. Look, see? Now it's like jumping around.
You broke it.
I know. It's.
What's your first number?
Not this one.
I know, right?
Spanish.
Uh,
I gotta go.
I don't know. My smartboard's like some type of ADHD elementary kid everywhere. Okay, so we're canceling them out, right? We're canceling those out. So now I have cosine of 1 over x. So now, let's again take it to infinity, right? Take that to infinity. So now we could try and plug in. So if we're trying to plug in, it's going to be 1 over infinity, which we said is going to be
0.
0. And cosine at 0 is
1.
It's all right. Cause I'm saved by a bell. All right. So, okay, for the people on YouTube, yeah, you guys know it's 1, right? Good.
Mister, maybe you have to take away the black coloring.
So the limit is 1?
It doesn't even say that it's black. It's not even on there. It's not even reading that it's on there. Okay.
Into the
All right, so let me pause this. There you go. Hopefully this is going to work. Okay, so find the limit of this. Now, there is a rule to go along with this. How about I just separate them? Can I separate those? Yeah, I could take the limit of the first one and then minus the limit of the second one. I can do that, can't I?
Yeah.
Okay, I think I can. But can I? I don't know. Okay, so let's see. If I try to do 0, try and plug in 0. Let me see. If I plug in 0 here, so think about it. As x keeps getting smaller and smaller and smaller, what's happening to my value though? We did this one yesterday. It goes what? Goes up, very good. So as I'm dividing it by less and less, that it keeps getting bigger and bigger and bigger. So that one would go up to infinity minus 1 over sine of x. Okay, so now think about it. Sine at 0, I can't really have that because sine is 0, right? Okay, so that one right there is going to be interesting because it is a wave and it's going to 0, but I can't have 0. Okay, let's go closer to 0.
Why can't you have 0?
Sine at 0?
Hey, how do you make that thing work? My whole thing don't want to work no more. It just went fritz.
That's a very, very loaded question. Like, no, like that's like, I know, that's like encompassing everything. So what thing are we talking about?
We're talking about the doodad right here.
This doodad?
Yeah,
Oh, the doodad.
yeah.
Okay, so does your doodad not do?
Hmm?
Dad?
No, it don't do.
It don't do?
The
Dad?
thing that connects to this thingamabobber, it don't work.
Wow, we're getting super technical now.
Well, I don't even know. Whatever that.
Okay, here.
That thing.
You know what? Do a limit. I'll go look. Go ahead. Try.
Bruh. God dang, you know how long it's been since I did a limit? I'm just doing freaking. Ooh, yeah. What's the rule for limits? You can subtract limits, huh?
Can you?
Yeah, you can subtract limits. So this is gonna be limit as x goes to 0. Oh, from the right, from the left, because it's going. No, it's coming from the left. It's coming from the right towards 0, right? Am I right?
Yeah, you're right.
Right, it's going this way, right? It's going that way towards 0 from the positive, right? All right, so this is 1 over x minus the limit as x goes to 0 from the positive direction towards 0 of 1 over sine x. Oop. Isn't that correct?
Yes.
Right? Well, as this is going to 0, isn't this blowing up?
Yeah, it goes.
It's just going up. This is going to infinity. This is going to infinity. Positive, right? Isn't it going? Isn't it blowing up like that? Is it blowing up like that? Sine. The limit of sine. 1 over sine. What is 1 over sine? 1 over sine is what? Cosine?
It's
Secant. That's right. There you go. See, I got. So this is already positive infinity. So this number's super huge. So it doesn't matter what secant is, huh? So.
But if you plug in 0, that just
Well, sine of 0 is what?
0.
Yeah, you can't have 0 down here. So yeah, this right here, I would say miracle happens. And then something. No, I don't know. Where is that? I forget that rule.
The eraser's right there. Right, yeah.
Right. Just like I threw him on the spot, he throws me on the spot. But he's a techie, you know what I'm saying? So this is positive infinity. And this is positive infinity. This right here is going to be what? Limit of x going to 0 from the positive secant of x. And secant of x is 0. That can't be good either, right? Right?
Yeah, it's undefined.
Yeah. So right there. I don't know what the rule is right there.
We're approaching it from the right though.
Yeah, but even still.
So not at 0, numbers to the right of 0.
Yeah. Oh, so greater than 0.
So it's
this.
also going to be infinity.
So it's diverging. It's going up. Right? It's diverging. So miracle happens. It diverges.
We're not trying to do Taylor series here yet.
Ooh.
So we don't need divergent.
Ooh. Right. Ooh. Well, I don't know what can you figure out my doodad?
Yeah, it's done.
¿A poco?
What the hell does that mean?
Really?
Yeah.
He forgot to push the on button. Okay, so either way, so this is going to be infinity. This is also infinity, because if you think about it, sine at 0 is 0, isn't it?
Yeah.
But slightly to the right of 0 is going to be a very, very small number, isn't it? A small number, isn't it? Say yes.
Yes.
Yeah.
So if it's a small number, it's 1 divided by a very, very small number, right? So that's going to be 1 divided, yes, it's going up to infinity, right? Okay, so this one right here doesn't really work out. And we need to actually try to manipulate this to be able to do this. So let's see. So let's go ahead and try and put these two together. Can we put them together? Yeah, common denominator, all that good stuff, right? Okay, so it's going to be, let's see, that's going to be sine x minus x sine x. Okay, good. All right, so now from there, we're going to actually try and do it from there. So now if we plug in 0 from the right, so it's basically plugging in at 0, it'd be 0 minus 0 over 0 times 0, right? Say yes. Okay, good. So that's 0 over 0. So that's what I was trying to get to. So if you notice, just plugging in directly, it would not work, would it? No, it wouldn't work. So I needed to actually manipulate this so I could actually have just a quotient rule like this. Not a quotient rule, a quotient like a numerator and denominator, so I could do L'Hopital. Now from here, let's go ahead and take derivatives. So the derivative of sine is cosine. So it's going to be cosine x minus 1 over the product rule of this is going to be sine x plus x cosine x. And we're still taking the limit as x goes to 0 from the right. So cosine at 0 is going to be 1. 1 minus 1 is 0 over. Now, sine at 0 is 0. So it's going to be 0 plus 0, right? Okay, again, I have 0 over 0, don't I? Yes. All right, so if I have 0 over 0, let's do it again. So if I do it again, derivative of cosine is negative sine of x. The negative 1 goes away. Over the derivative of sine is cosine, right? And then this is again going to be a product rule. So it's going to be cosine x plus x negative sine x. So now plugging in at 0. Plugging in at 0 now, sine is going to be 0. Okay, so I have 0. Over, now, 1, 1, and 0. So it's going to be 0 over 2. So remember when we were doing this the other day and I said, hey, you know what, if we get 0 on top, it's fine. 0 on the bottom is no-go. So this one, I now have a number. 0 is a number. So as this goes to 0 from the right-hand side, I'm going to get the answer of 0. All this stuff is just manipulation. Trying to make it work. Trying to actually see. Whenever you see a limit from this point on, you're going to look and be like, all right, I'm not going to do the limit. I'm going to do the derivative. I'm going to do L'Hopital's rule. The key to that is, though, it only works if there is the indeterminate. That means that I have to have, okay, certain things. Now, for this one right here, we have more. This is indeterminate if the type 1, which is 1 to infinity, 0 to 0, or infinity to the 0. Okay, let y equals f of x to the g of x. Take the natural log of each side, obtaining, okay, so for this, obtaining ln y is equal to g of x times ln of f of x. And then find the limit as ln of y as x goes to c. So if this right here is equal to a limit, then the limit of ln y as x approaches c is y equals e to the l. What? Someone just said no? I heard no. Am I tripping or am I just like, did someone just say no? Maybe? You guys do not like that here or there. I'm telling you, you guys missed out. Okay, I blame the right cow. You guys missed out on LNs. LNs and logs, those are interesting. They're puzzling. I know, but you got to do it in a way that you're like, oh, okay. You know what? It should be a natural occurrence, like natural log. Anyway, yeah, I did that. X to the x.
0 to 0, right?
0 to 0. There we go. So this would be 0 to the 0, wouldn't it? Okay, so go back. What did it say to do? F of x, right? F of x to the g of x, right? So it's going to be, right? F of x is one thing and g of x is the other. Okay, so let's see. Y equals f of x to the g of x. Then, okay, logarithm each side. Okay, so you should get g of x is equal to ln of f of x. So ln y, so ln of y is equal to g of x, right? G of x times ln of f of x. So g of x is going to be x times ln of x. Does that make sense now?
No.
Go ahead, Friday, speak.
Yeah, why we use ln and not log? Doesn't that like require like e's and stuff?
Yes, it does, e's. Now, it's natural. E's and ln's go together. They replace each other. So if you take an ln of an e, it cancels out and gives you 1, or whatever you have. Okay? ln of e or e to the ln. So those cancel each other out. And so, but if you did logs, logs have different bases. ln is just a log base e. That's all it is. Natural log, that's why it's natural log, ln, is log base e. So if I were to write it out, it would be log of e of x. That means ln of x. So the same rules apply. But these are interchangeable all the time. And so by using natural log, it makes everything work out a whole lot easier. So you can use, different log rules with different bases, but it makes the math harder. Okay? So we're going with what they have right here for the reasoning on this, though. Okay, so I'm able to get to this point right here. All right, so now we can look at this. Now let's look at it. So we have this. Now we're finding ln of y, okay, as x approaches c. Okay, so right here, it's going to be the limit. Okay, so let's do that. So for this, all over this is going to be what I'm finding here. Okay, to be able to do that, let's go back. What do I have to do here?
The x on the bottom.
There we go, right? So it's going to be ln of y is equal to ln of x over x to the negative 1, right? Plugging in at 0.
Negative infinity over infinity.
Okay, so yes. So this one's going to be, it's negative infinity over infinity, right? Because ln 0 does not exist. It goes down. Remember, we had a graph where we looked at what ln does as it's approaching 0. It goes down to negative infinity. And then same thing goes for this. So as I make this infinitely small, coming towards 0, infinitely small going towards 0, this is going to infinity. So that works out again. I have L'Hopital now. Now I can use L'Hopital's rule on this. So now let's go ahead and do that. So this is going to be the derivative, which is going to be 1 over x over negative 1 over x squared, right? And I don't like fractions over fractions, do I? Nope, no fractions over fractions, so I have to multiply by the reciprocal. So when I multiply by the reciprocal, it's going to be 1 over x times the reciprocal of the bottom, which is negative x squared over 1. Yes. And I could cancel out one of those x's because I should get a negative x over 1, right? Now can we plug this in for 0?
Yes.
Okay, so now we plug it in. So as it goes to 0, this is going to give me 0 over 1, which is just 0.
You have to do anything with the ln y.
Okay, yes, now it goes back, right? So we're going back to the rule of what it said over here. So then, right here, it is going to be the limit as this. It gives me e to the limit. My limit is 0. So it should be the limit of y, crap. Of y equal to e to the, what was my limit? 0. And anything to the 0 power is 1. So this is going to give me the limit of y is equal to 1. Interesting? Okay. Indeterminates. Okay? These are on your flashcards. The new set of flashcards that I gave you. Okay, so I'm gonna try and give you guys the rest of this time. Get as much done as you can. Like, share, and subscribe. I'm gonna post this because it's gonna be a funny video.